is Titus Kim, and today I'll be teaching you the basics of trigonometry. So in trigonometry, we use trigonometric ratios. So if we have sine, cosine, and tangent. With these, we have something that can help us with the ratios. So we have so, ca, and toa. These might not seem much to you right now, but by the end of this video, I hope you'll be able to understand them. Okay, so in trigonometry, we deal with right triangles, and so the OHA, they all stand for different things. So the O is the opposite, the A is the adjacent, and the H is the hypotenuse. So opposite of this right triangle, we always have the hypotenuse. And the trick to successfully answering a lot of questions is basically labeling your triangle correctly. And so if we have a triangle like this, or something that's not right triangle, we can't really use we can't use these trigonometric ratios on them. Okay, so let's see. If we have an angle, say theta, right here, then the opposite side of it, let's point an arrow to it, is the opposite. And the adjacent side and the side beside is the adjacent side. This is if theta is over here, but if theta were to be on over here, it's not. Theta's never really here. If theta were to be here, then the opposite side would now be down here, and the adjacent side would now be here. So, what do we use so, ca, and toa for? Perhaps we had theta right here, and we wanted to figure out, okay, I'll give you an example question. It's 43 degrees, 12, and x, and we wanted to figure this side length out. Then we would find this length by using one of these trigonometric ratios. But for now, let's look at something else. Okay. Okay, let's look at so. The S stands for the sine, and then we have an angle, let's say theta, and this is equal to the opposite over the hypotenuse. So we say opposite over the hypotenuse. So if we have a triangle, right, and we have theta right here, and this is the opposite side, opposite, and this is the right angle, so this is the hypotenuse, and then this is the adjacent side. Sine, so S, is opposite over hypotenuse. So if we knew this length and we knew the angle, then we could obviously find the hypotenuse. Okay, let's look at cosine. So ca, and then there's toa. So this one is obviously cosine, and then cosine, let's say angle is theta, equals the adjacent over the hypotenuse. So adjacent over hypotenuse. Okay, and then finally, tangent, which is toa, so ca, toa. This is tangent, and we can say theta, and this is opposite over adjacent, so it equals opposite over adjacent. Okay, now we can start to look at a couple of questions. So the example, going back to the example I showed you before, let's draw a right triangle. Oh no. We have the angle 43 degrees. This is a right triangle. And this is the side we're looking for. And we have 12. So if we look at so, ca, and toa, we can try to figure out what ratio we can use, sine, cos, or tangent. So Since we know the opposite and the hypotenuse, we can use the opposite over hypotenuse. So we can use sine. So let's write down sine. Sine usually is written like this, cosine and tangent. But when writing them, we use the short form, sin, but we still call it sine. So sine 43 degrees, 43. So it's the opposite over the hypotenuse. So opposite, which is x, over the hypotenuse, which is 12, equals that. So now, with that knowledge, we can easily solve for sine. So how do we do this? We multiply 12, and then this will be multiplied 12, and then these will be canceled out. And so now x equals 12 times sine 43. And right now this can only be done using a calculator, and we get the answer, x equals 8.184. Okay. In a calculator, there are two modes. You can have a radian mode and a degree mode. Right now, I calculated this in degree because radian is a little more advanced, and radian is typically used in when you're doing circle trigonometry and circle trigonometry, trigonometric identities, and so on. So right now, everything is in degrees. Let's try another example. If we have another triangle, a right triangle, and we know this degree this time, and we're looking for, say, the hypotenuse, and the side length right here, we know is 5. What trigonometric ratio would we use? Yeah, so if we have Cotangent, let's write these down again. These really help to find out which one it is. Since we know this is the opposite side, so we can write down opposite if we want. This is the adjacent side, and this is always the hypotenuse. So we know the adjacent and the hypotenuse. So that leads to the conclusion that we can use cosine. So if we have cosine, and we know the degree, instead of theta, it's 27 degrees, and we make that equal to the adjacent side, so A, 5, over the y. And now we can solve for y, and we can see that y equals equals 5.612. Okay. Now we've solved for sine and cosine, but what about tangent? Okay, let's do a tangent question then. So we have another triangle. We have a right angle triangle. We're looking for this x. We have 10 here and 30 degrees. We have no hypotenuse, right? So and if we look at, we did so, and we did ka, and now let's look at toa. If you look at toa, there's no h in it, so that means there's no hypotenuse. It's opposite over adjacent. Okay, so we have this degree here. We have the opposite over the hypotenuse. So it's x over 10. So if we have tangent 30 degrees, then what would it be? It would be x, the opposite, over the adjacent. So x over 10. Now we can just multiply this by 10 to cancel these out, and then we would multiply tan 30 by 10. So tan 30 times 10 is, so x would become 5.774. Okay. In trigonometry, getting a little more advanced now, Not really though. We already learned about sine, cosine, and tangent. These are the three basic ones, but there's three more ratios. So there is cosecant, secant, and cotangent. So we write them in short like this. So if we have an angle, sine theta, cosine theta, tan theta, cosecant, we write CSC theta, and I'll tell you what this means right after I write these. This is secant, CC theta. SEC theta, and cotangent is written like COT theta. So if we have these normal ones, this one is related to this one's related to this, and this one is related to this. But with what relation? Okay, so cosine, this cosecant, we can rewrite it as 1 over sine theta. So it's basically the reciprocal, yeah. So what would this be? This would be 1 over cosine theta, and this would be 1 over tan theta. Yeah, using this we can, if we have a triangle, let's get a triangle. If we have a degree here, and we know the two sides, what should we say? Let's say it's theta, and we'll give the side length to be 3, and this should be 4 then. Let's make that 4. Then we need to write down all 6 trigonometric ratios. So sine theta, cosine theta. So sine theta is opposite over hypotenuse, but I'll show you this. Sine theta is just opposite over hypotenuse, right? But if we have, remember the reciprocal one, the flipped over one, 1 over something, this would be cosecant theta. We flip it over, right? We flip it over, so we have hypotenuse over the opposite. So if we can find this length, we can find all 6 trigonometric ratios with theta in it. So let's do that. How would we find this length? Well, we know Pythagoras' theorem. A squared plus b squared equals c squared. So let's use that. There's 4, there's 3, and then we can find that. So 4 squared plus 3 squared equals, let's say this is x. Then we can say this is x squared. So we have 4 squared is 16, 3 squared is 9, then it equals x squared. So 25 equals x squared. Now if we square root both sides, the square root here cancels out, and we have x alone. And then the square root here, we do the square root here, and we get a 5. So x equals 5. So we can say x equals 5 right here. Now if we, let's rewrite everything again. So we have 4, 3, 4, and 5. So 3, 4, and 5 now, and this is theta. And we have to write all 6 trigonometric ratios. Then let's see, sine theta. Sine theta, what would that be? That equals opposite over hypotenuse. So 4 over 5. Okay, easy enough. Cosine theta, what does that equal? Cosine, remember, so A over A over H, so adjacent over hypotenuse. So the adjacent to this is 3, and the hypotenuse is 5. So 3 over 5. The denominator is the same because they're both the hypotenuse. Okay, finally, tan theta. Let's see, what was this again? TOA. So opposite over adjacent. So let's say the opposite over here, 4, over the adjacent, so 3. So 4 over 3. Now let's take a look at some of the other ones, like the cosecant, secant, and cotangent. So if we have cosecant, that is the flipped over. So if sine was opposite over hypotenuse, so opposite over hypotenuse, then this would be hypotenuse over opposite. So we can take a look at this thing right here, and we can use it over here. So it'd be 5 over 4. We just flip it over. And then we have secant. We just flip it over. And finally, we have cotangent theta, which is 3 over 4. So this is this is the basics of trigonometry taught by Titus Kim. I hope you enjoyed, and I hope you learned a little bit more about trigonometry. Thank you.